Okay, so in this video, we will be going over quiz 5 and pretty much what to do for it. Disclaimer regard this all stuff. Apologies. All right, so the question is pretty much asking what is the mu of this box right here. So what do we have to do? Well, we are given everything except the mu, and we are solving for that. So what do? We set up our 4 equations. So 1. So the mechanism is going to the left, which is indicated by this arrow. And so what do? Well, we set up the equation closest, to the direction it's going. So we do force equals ma. So m is 25.5. These are all in kilograms, by the way, times a, which is 0.311, equals, so this is the tricky one because it's on the ramp. So pretty much it's going this way, and we know how to do that, which is mg sine theta, and we know all those, so we can do that. So it's 25.5 times 9.81 times sine 68.5. Now, so that's that force going that way. Now, what is holding that force back? Well, think about it. Obviously, friction is, and what else? The tension. So it is minus T1, because that's the tension, minus the friction. What is friction? Well, it's this right here. Friction equals mu times normal force. So we don't know the mu, so mu is like this, times the normal force. How do you find normal force? Well, like we did in the previous unit, or previous lessons, it's mg cos theta. So it's 25.5 times 9.81 cosine 68.5. That is the first equation we set up. Then the second one we set up is for the 14.3 box. So once again, ma 14.3 times 0.311, because that's ma, that's the net force, equals, so let's think about this. We need to cancel out the T1. So what do we need? We need a positive T. So it's T1 minus this tension minus that tension. T1 minus T2. And now we can pretty much subtract the friction that's holding it back. Minus 0.177. What is friction? Well, we just did it. So then we know the mu, and we know the normal force is just pretty much mg. So 14.3 times 9.81. So that is the second equation we set up. Then number 3, the third equation, is for this 10.5 box. So 10.5 times acceleration, and we get pretty much, so it's sort of the same thing. We have a negative T2, so we need a positive T2 for them to cancel out. So T2 minus the other tension acting on it, T3. And then again, it's the pretty much exact same scenario. It's the friction, pretty much. So mu is 0.226 times 10.5 times mg, which is 10.5 times 9.81. Now that is the third. Now we need the fourth, and this is actually probably the easiest one. So it's net force is 17.2 times 0.311, because acceleration is the same throughout, equals, and so pretty much it is, once again, we have a negative T3, so we need a positive T3 minus, and it's just mg, because there's no friction. So 17.2 times 9.81. So that is how you set up all these 4 equations. Now what can we do that? Well, we can cancel out all the tensions. So let's see. We have a negative T1 and we have a positive T1. Cancel, cancel. We have a negative T2, a positive T2. Cancel, cancel. We have a negative T3, a positive T3. Cancel, cancel. Now all we're left with is what we're trying to find, which is our mu. So how do we do that? Well, we add everything up. And yeah, let's go from there. So adding them up, so we add all these up, and we can get 20.99, which comes out to 21.0, equals, so this is actually going to be pretty big. So it's we have whatever's left over. 25.5, 9.81, sine 68.5. This canceled, so minus mu 25.5, 9.81, cos 68.5. This is actually going to probably go off the board. Then minus 0.177, 14.3, 9.81, minus, 0.226, 10.5, 9.81, minus 17.2, and 9.81. Now, what can we do? We do solver, beloved solver. So I'll do this right now. Then, after plugging this monstrosity into the solver, you should get mu equals negative 0.0555. So if that's not a calc error, this is what you should get. And once again, if it is a calc error, he doesn't take any points off, so you should be fine because this is how you set up the equation. So there you go. Okay, our next question pretty much asks to find all the tensions. 1, 2, and 3. So we have this pretty much, this mechanism right here. And T1, the angle is 35 degrees. T2 angle is 61 degrees. So we can first, what can we first do? We can easily solve for T3. How do we do that? Well, it's the only thing that's acting on it is mass and gravity. So it's pretty much mg 10.0 times 9.81. And that becomes simple math, 98.1 newtons. So T3 we can confidently say is 98.1 newtons. Now, the harder part is finding T1 and T2. So let's split this up into X and Y. So in the X direction, we can pretty much make T1X equal to T2X. T1X equals to T2X. And that is pretty much what we can set that up to. And then in the Y direction, well, so, and by the way, this can be simplified to T1 cosine theta. What is the theta? 35 degrees equals T2 also cosine theta. Theta is 61 degrees. And so we can set those up. Then on the Y direction, we can do T1 sine, because sine deals with Y, 35. And then we can add these two tensions in the Y direction, and they will actually equal the tension in T3, because they everything cancels out in the end. Plus T2 sine 61, and that is going to equal our T3, which is 98.1. So after setting these each up, we can simply solve for T1 or T2, and once we isolate T1 or T2 here, we can plug T1 or T2 into T1 or T2 here. So let's just decide on one. It doesn't really matter. Let's just do T1. So T1 equals T2 cosine 61 divided by cosine 35. So then we can plug in this into T1. So T2 cos 61 divided by cos 35 times sine 35 plus T2 sine 61 equals 98.1. Now we can realize that we only have T2 as the only variable here. Now let's go to our solver, and we get 98.1 equals, boom, X, or T2, cosine 61 over cosine 35 times sine 35 plus X sine 61, and set that to 0. and our T2 comes out to 80.1 newtons. So now we have T3, T2. All we need is T1. And how do we solve for it? Well, let's just plug it back into our original equation. So T1 cos 35.0 equals T2, which we just solved for, 80.1 cosine 61.0. So we can isolate T1 here equals 80.1 cosine 61.0 divided by cosine 35. So let's do that right now. 80.1 times cosine 61 over cosine 35. And as our T1, we get 47.4 newtons. So that is how to find all of those tensions in this three-body diagram.